Alright, so we're on to lesson 7 of our geometry unit. It is focusing on the area of polygons through the composition and decomposition. And our I can statement is, I can use absolute value to determine the distance between integers on the coordinate plane in order to find the sides lengths of polygons. So let's look at some keywords here. This word composition means what? Well, composition means to construct or make through the construction or deconstruction. Now what does this prefix mean though? This prefix de, well, that means not. So not construction. So I'm going to find the area by constructing and deconstructing or taking apart shapes. We have this word that we saw at the beginning of the year, absolute value. Absolute value is how far something away is from 0. So example, -2, if I plot it on a number line, 0, -1, -2, the absolute value is how far away? Well, it's 1, 2 jumps away. Absolute value is always positive. And a coordinate plane we should remember as what? Well, just as a graph or a grid that we plot points on. Okay, so let's continue. Here's a short little video on absolute value, in case we forgot.
Absolute value. The absolute value of a number is its distance from another number on a number line. Distance is a measurement that tells you how far you've gone from one point to another. The notation for absolute value is 2 straight lines, like this. The absolute value of 4 is 4, because 4 is 4 places from 0 on the number line. -4 is also 4 places from 0 on the number line, so its absolute value is also 4. Absolute value is always a positive number because it's the distance from the other number, in this case 0, no matter the direction. Here's Lucy. She needs to walk to her tuba lesson 3 blocks from the bus stop. After walking 2 blocks, she realizes she dropped her sheet music. She goes back 1 block, finds it, then continues to her lesson. One way to represent Lucy's journey is like this. By walking 2 blocks forward, 1 block back, and 2 blocks forward, Lucy ends up 3 blocks from the stop, yet she walked more than that. Absolute value shows us how much she actually walked. 2 blocks forward, plus 1 block back, plus 2 blocks forward, for a total of 5 blocks. Phew! Absolute value can help us calculate distance and solve math problems.
Alright, so let's continue. So here we have a coordinate grid with some shapes and lines on it. So what we want to do is we want to determine the lengths of the given line segments by determining the distance between 2 endpoints. So we're looking for the distance between 2 endpoints. So for example, endpoint here and endpoint here. How far away are they? Okay, so let's start by filling in our chart. Well, I have a line segment, A to B, and so I need to put its points. What is A and what is B? So I'm going to look on my graph. It's 1, 2, and I went to the left, so that is a -2, comma, how far up it went. It went 1, 2, 3, 4, 5, 6, 7, 8. And then my B is, I go over 1, 2, 3, 4, 5, 6, 7, 8, 9. And how far up do I go? 1, 2, 3, 4, 5, 6, 7, 8. Let's check our answer. So now my easy part is I need to know their distance. So I'm going to start at A, and I see how many jumps it takes to get to B. Well, it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And let's check our answer. So I'm going to do the same thing for each of my other points. So now I have B to C. Well, I already know B because I just found my last one right here. So I'm just going to copy it. And let's see if there's anything else that I can look at. Well, I'm looking at now B to C. So where is C? C is right here. So let's continue. C is 1, 2, 3, 4, 5, 6, 7, 8, 9 over. And how far up did it go? Well, it went up 1, 2. Let's check our answers. So now I need to know its distance. How far is it from B to C? Well, let's check. 1, 2, 3, 4, 5, 6. So its distance is 6. Check our answer. Let's go to our next one now. C to D. Well, I already know C is what? C is 9, comma 2, because I just found in my last example. So I'm just going to copy that down. And now what is D? Well, it is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is also 9 over. And how far down? 1, 2, 3, 4, 5. Notice how it's a negative 5 though, because we're going down. Remember, whenever you go down, it's a negative number. Whenever you go to the left, it is a negative number. So this is 9, comma, negative 5. Let's check our answer. And now, how far away is it? Well, it is 1, 2, 3, 4, 5, 6, 7. Check our answer. Okay, I want you guys to finish filling out the points. Don't finish the distance yet. Finish the points. After you are done, continue the video. So you'll need to pause it. Alright, let's see if you got your points ready. Well, did you get for B to D? Did you get 9 to 8? And did you get 9 to 5? How about for the rest of them? Do the rest of them match up? Check your work. Okay, so now we have an easy task before us. Now we just need to figure out what? We just need to figure out its distance. So let's erase all of my work on here. And now let's check. So we're just checking our distances. From B to D is how far? Well, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. D to E is how far? Well, let's check. D to E is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's check our work. And it's 11. Okay, I want you to finish up the rest of the distances. So you will need to pause the video. Alright, let's check. Are these the numbers you got? Hopefully they are. Alright, let's continue. What did you notice about each pair of points? So remember, a pair is 2. What do you notice about this pair? Or this pair? Or this pair? You should notice something. You should notice that the x-coordinates are the same, or the y-coordinates are the same. They have some repeating numbers in there. So see, 8, is the same as the y coordinate on the other point, 8. And this one, 9, is the same as the x coordinate on the other one. Notice how every single one has a pair that is the same. And this is going to be very important. It's going to be saving us some time as we continue our lesson if we can see that they will always have some kind of matching coordinate. So, how could you calculate the lengths of the segments using only their coordinates of their endpoints? So instead of having to graph them, what could we do to see if we can figure out some kind of relationship? Well, let's see. Is there some kind of relationship between 9 and -2? Is there some kind of relationship between 8 and 2 to this 6? How about from 8 and -5 to 13? How about -2 to 6? Is there some kind of relationship? How about 6 to 8? Is there some kind of relationship to 2? Hopefully you're seeing a pattern. We can subtract the absolute values of the endpoints if both points have the same sign. So if they're both positive or they're both negative. So let's look at an example right here. Here I have the signs that are the same. 8 and 6. They're both positive. If I subtract them, what do I get? I get 2. The absolute value of 6 equals 2. 8 minus 6. What about this one? If the signs are different, we add their absolute values. So if I have one positive, one negative, I'm adding their absolute values. So let's look at this one right below on F to A. Well, if I have the absolute value of -2 plus the absolute value of 8, well, that's going to be 2 plus 8 equals that 10 right there. Please write this sentence down on your notes. All right, let's continue. Okay, so here I'm going to do just some proof solving. We see 9 plus -2. We're adding them. Why? Because they have different signs, a positive and a negative. Here I'm adding because there's different signs. So you're just going to do some proof checking on these. What do I do with this one right here? Well, this is going to be the absolute value of 8 minus the absolute value of 2 equals 6. Why is that? Well, because this is a positive 8, this is a positive 2. And remember, if they have the same sign, then we subtract. Okay, so let's check. I'm going to do the same thing for each of these, and you'll notice it's the same distance as what? The same distance that we got when we were counting. This distance matches that one we got when we were counting. All right, here's your turn. I want you to complete the table using the diagram and the coordinate plane. Here's your first example for you. And here's another example. All right, please continue. How'd you do on these two? Hopefully you got them right. Let's check these ones. All right, check your work. How did you do? Hopefully you did well. All right, here's our next part. For each problem below, write the coordinates of 2 points that are 5 units apart. So I'm going to find my key information, 5 units apart. And I'm going to have what? 2 points, so 2 dots. So let's begin. The segment is vertical. Well, vertical means what? Vertical means that it goes up and down. So I'm just going to pick any point. I'll just start right here. And how far away should they be? Should be 5. So I need to go 5 up or 5 down. So I'm going to go 1, 2, 3, 4, 5. Okay, so here I have my line segment. And it doesn't say, though, plot. It says write. So I need to give its coordinates. This is 1, 2, 3, 4, comma 0. And it went up 1, 2, 3, 4, 5. So it's 4, comma 5. So this answer for vertical is 4, comma 0 and 4, comma 5. There could be many other answers because if I did this one and this one, they're still 5 units apart. So you could have any other kind of answer as long as they're 5 vertical units apart. Let's check this next one now. It says the segment intersects the x-axis. Well, let's take what we just did, this 5 and this 0. Let's just shift it down so that it intersects or what? Crosses. So here's one dot and it needs to go 1, 2, 3, 4, 5. Does it cross the x-axis? Yes, it does. So I just need to give it its label. So this is going to be 4, negative 2. And this is going to be 4, 3. So it's 4, comma 3. And what? 4, comma negative 2. Okay. Here's our next one. The segment intersects the y-axis. So remember, intersect means what? Intersect means crosses. And y-axis is this line right here. So it needs to cross that line. So let's just pick a point. And how far does that have to be? 5 units. So I need to go 1, 2, 3, 4, 5. And I need to write them out. So this is 1, 2. 1, 2, 3, 4. 4, comma 2. What do you notice is wrong about that? Remember, my left to right always goes first. So it's actually 2 because that's my x-axis. I went up 4. This one's going to be 1, 2, 3 to the left, so that's a negative 3. And it also went up 1, 2, 3, 4. So let's write our coordinates down. Okay, let's continue. Here's our next one. The segment is vertical and lies above the x-axis. So it's vertical, meaning up and down, and it's above the x-axis. So it's going to be above this line right here. So let's pick, if I pick this dot, can I go above 1, 2, 3, 4, 5? Well, I can't go off my grid. And if I go down 1, 2, I've passed that x-axis. So I can't use that dot. So let's pick another one. Let's get as close as we can to the x-axis without actually touching it. How about right here? Can we go up 5? 1, 2, 3, 4, 5. Yeah, I can. So now let's continue. Let's check. Is it 5 away? 1, 2, 3, 4, 5. So what are my dots? Well, this is 5, comma 1. And this is 5, comma 6. All right. Closing. So our last part. What did all the segments or lines used in the lesson have in common? Well, they had this all in common. They were all either vertical or they were horizontal. There were some other similarities, but those are the main things we were looking at, vertical and horizontal lines. How could you determine whether those segments were vertical or horizontal given the coordinates of their endpoints? So for example, if I just gave you this, 8, comma 2, and 8, comma 3, is this a vertical or is it a horizontal? Well, let's look back at our lesson. What did I notice here? They have the same, and B to I is where? B to I is right there. So it looks like if their x coordinates are the same, then it is vertical. Now let's check. What if they had the same y value? So let's see. -4, -4. This is G to H. They have the same y value, then they are horizontal. Why? Well, because if they have the same y value, they're not going up or down. So what can we determine? Well, if the x coordinates for both points are the same, then they are vertical. X coordinates, same, vertical. The y coordinates are the same, then what? Then they are horizontal. How did you calculate the length of the segments given the coordinates of the endpoints? Well, this is what I had you write down earlier. The coordinates were not the same because they didn't have the same sign. Then we subtracted them. So if I had a positive and a negative, I subtracted the absolute value. If they were the same, then I would add the absolute value. Okay, so here's your exit ticket. Please fill this out. So your point, distance, and then your proof. If you're unsure what proof means, go back to your notes. When you are done, go to Khan Academy. You have one lesson to do. Then you may play math games. All right, good luck.